Okay, to all structure engineer, to all steel connection design engineers, how are you doing today? Today, I'm going to show you how to use silver-based steel connection program to design brace connection. Okay, the brace connection including vertical, horizontal chevron, and base plate, vertical brace, knee brace. So basically, we follow the AISC design guide 29 for vertical brace, and the same rule apply to horizontal all other braces. Okay, and the force distribution between the interface force like gusset plate to beam gusset plate to column, and beam to column is interface force distribution. We adopt the uniform force method. All right, so for vertical and horizontal brace. So I start using the Opera browser this time because it's much faster. I think it's faster than Chrome. Okay, Opera browser. See here, I start Opera. All right, so typing the address, ASP Silvey, okay, .com/connect. Okay, you typing this one, you will start an interface. Right, that's Opera. That's first time we use this browser. Okay, you probably get the start connection type as MC. We change to brace. Okay, brace connection. So this tutorial will be the first part of all brace tutorial, and we focus on the these brace to gusset. Okay, there's a connecting member, type of member connected, because in terms of brace, we talk about this part, the brace to gusset. In terms of brace member, there are a lot of variety. Okay, and like the way how the brace connect to gusset, there are lots of way, and there are lots of different type of members. So, and you notice we turn on the tooltip here. I will just show you some. So go to General tab. Okay. First, of course, is company name and project name, connection ID, brace connection. We just choose. Okay, it's a moment shear brace splice. Okay, and there's also selection for you to choose vertical, horizontal wrap plate, and chevron, knee brace, vertical brace, base plate, brace connection type. There also is option for you to choose column to be on the left or right. We'll talk about this later. Okay. So column left and right. Okay, we talk about this now. Okay, so if you choose to the right, you will just flip, mirror it when the column go to the right. Okay. Oh, it takes so long. Okay, column the right. So okay, so the brace could be there's one corner brace, top only. There could be bottom only. Okay, we have bottom only. I can have brace top and bottom. All right. Okay. Top and bottom. That's the brace. Okay, and also the brace for this case. The brace is connected to column web. Okay, then it can be connect to column flange as well. Okay. All right, let's brace connect to column flange. And also the beam. Gusset brake now is to call beam flange. It can rotate 90-degree gusset connect to beam web. Okay. All right, so you see the front view, even notice that, okay? You see the front view, and the gusset is connect to beam web. Okay, gusset is connected to beam web. Okay, the beam is too huge. It's out of range of the column. But anyway, you can choose a small size beam. All right, so let's say we choose beam size to be W8. Okay. Instead of 1230. Beam section, okay. Now it's 1230, we change to W8. 24. 824, I like 824. All right, so it's okay. So now we have go to front view. We have small size beam depth. Now, so it's not a common seam case, okay? The beam lay web horizontally. It's not a common seam scenario, okay? So we turn it back to be connect to beam flange, okay? In this case, I just show you we have the option of doing this type of connection. That's it, okay? So we change to flange. You see the beam will rotate 90 degree. So now, here you go. Okay, so that's common scenario for these brace frame. All right, so we have W8 24 beams. Okay, we have W8 24 beams. We have combined end plate, and then above and below we have these brace connection combined as a one single end plate. Okay, go to the side view. Okay, so basically I show you these input here. We can get the column to be right side or left side. We can have the brace top only, bottom only, or top and bottom. We can have this gusset connect to the column weak axis or strong axis, and beam can be weak axis and strong axis as well. So someone may ask, okay, if I have these cross, like British national flag, we have brace on both sides of column. Are you able to design that? I would say yes, okay. The thing is now, if you have brace on both sides of column, we can design it as this case. with brace on one side, top only, bottom only, or top and bottom both. And we can mirror it, okay? We design the other side. The connection, let's say we have a brace on this side, okay? We can go for another run of input, another pass of input with column F left, okay? We can do another pass of design by choosing this scenario, okay? The connection between the left and right, okay, is just transfer force or pass-through force, okay? So all you need, you can design the brace on the left to column. You can design a brace on the right to column in two runs, all right? Separately, not in one input load, okay? You can design them separately. The relationship between these two runs, okay, two separate connection design is just pass-through force, okay? There's no other, you can do it separately. The only connecting part is this pass, see this AB, 15 kips, okay? It's pass-through force, that's it, okay? Do it separately, and the way how they connect to each other is just pass-through force. Let's answer the questions. We can do this type of connection. And go to the next, okay? Let's manipulate of column strong axis, weak axis being strong axis, weak axis, how the gusset connect to them. Then come to the next, the type of section, brace section, okay? Pretty much that's two tips, all right? You can visit two tip. Okay, we provide the most variety of section type based on a couple category. As a wide flange, there are 1, 2, 3, 4, 5 ways of connecting wide flange to gusset. Okay, there are 5 different way of connector. We will address this one later on. Okay, let's call the first one is block flange. We cut the flange half and connect the web to gusset. Excuse me. The second type is the web plate. The third type is the creep angle. I will show you later on. Okay, the 5 ways of connecting. And also WT is just one way. Okay, angle there are 1, 2, 3, 4. Okay, 4 way how you connect angle and double angle. Okay, and channel. Okay, that's one way. And the hollow section is 1, 2, 3, 4, 5. 5 ways of connecting the hollow section. Okay, that's the number one point I want to show you on this brace connections. The brace connection section type. We provide the most variety of section type. None of the other program provides the number of variety of section type as us. Okay, so we to run faster, we only have brace at the top. Okay, we want to simplify the demo. Okay. We only want the brace. Okay. So, we want to show you this one. Okay, connection section type. We turn the 2T off for now because I don't want it pop up every time. We turn the 2T off. All right. now we have WT section. Okay, that's most common one, WT, and that WT can be for front of gusset. What is shown now, it can be back of gusset. Okay, you can okay, it's a back of gusset. And also, okay, this one, okay, we want this one well to be gusset to be come straight. Okay, let's say we copy the suggest value. That one comes straight. Okay, this line to come straight. Copy the suggest value. You will just go straight. Okay, perpendicular. You add one more rows of bolt here, gusset to column. I'll probably add one more row, yeah. Number of bolt rows. No, not this one. 3 column. Okay. So we have 3 columns of bulbs and this one. Now we go back. We go back. Okay. So I'll start showing WT. All right, that's one way. Section type, brace section type. First one is WT. Now we want to show you W shape. Okay, Y flange. How this one connect to gusset. Okay, there are a couple ways. All right. So okay, that's the heaviest one. Okay, apparently I had to add more rows. That's heavy brace section. Okay, so gusset to column. Let me add 3 more rows of bolts. Okay. That's heavy brace connection. Let's say 1, 2, 3, add 5. Okay. Try to expand the geometry size of the gusset because it's heavy brace connections. Okay, go to gusset to beam. I will just copy the suggest value. Alright. Copy the suggest value. Alright, so go to general. Now that's W type of brace sections. That's W shape. That's heaviest W shape brace. Okay, the brace load pretty much is close to 100% of the W shape tensile capacity. Okay, or at least more than 50, like 65, 75 of W shape wide flange tensile capacity, heavy brace. Okay. We connect, that's the way how we connect. We connect through 2 creep angle on the flange to web plate on a web, okay, achieve 100%, almost 100% of W shape brace capacity. And that's W shape. First connecting type of W shape. The other one will be block flange. It's a lightweight W shape connecting type. Okay, block flange. We cut the flange. And we only connect it to the web. A couple of bolts. That's block flange. Okay. Now it's to here. We don't want to adjust this moment. I will show you later on. We can adjust this one to cut short. Okay, that's block flange. I will show you on the two tips. Okay, W shape block flange. I turn it on. See, the block flange is we cut this flange, okay, get a gusset, connect to the web. That's block flange. Okay, so we can choose brace web with web brace. Okay, that's most common type of W shape connecting type. Okay, that one gusset to beam. I will just copy. Keep adjusting the number, the gusset geometry too, because different way of connecting, different way of gusset to column. I will just reduce it to now it's 5. Different connecting approach has different footprint on the gusset size. So I go to 3. Okay, this guy. I go to 3. All right. So that will reduce the. You see, the gusset plate geometry are smaller for these two type is connecting by the web or block flange. Okay, go to general. It's a small size gusset plate. These are two lightweight. The web plate connecting type can take more load than the block flange. All right, so W shape, you see here, we show you this block flange. Now we show you this brace web with web plate. Okay, that's what is shown now. With small footprint of gusset. This type is normally is good for it's double shear with double side shear frame. It's good when your brace is three critical connections. Okay, you double 3 critical connection capacity because it's double face of interface plate. Okay, friction on double sided. That's the second type. This one. Okay, now we go to this. A brace web with crit angle. That's what brace web with web plate. Now we go to this type. That one, I will show you that. Okay. Brace web with crit angle. That's okay. That way of connecting wide flange is all right. Okay. That's how use a 4 crit angle to connect the gusset plate and wide flange web. Okay, that's not common same ways of connecting wide flange to gusset. We do this when this wide flange connection, wide flange brace is X type cross bracing. Okay. When you go to X type cross bracing, your in-plane brace length is cut to half, and your out-plane brace length is full length. That's my way of designing thing. Okay, some engineer might argue, hey, the tensile brace always acting as a brace point for compression brace. I couldn't agree with that. I was always take the in-plane brace length to be half and out-plane brace length to be full. And in that case, we want to take the strong axis radius, larger radius of directions. For strong axis, we have to connect a wide flange in this way. Okay, in this way, the out-plane R value is fully utilized. You have double unsupport length, but the radius of direction R is also large value, strong axis value. Then we can get this brace member design pass. Okay, we design this way. And also the other way we use this type of connection is for horizontal brace. We want this wide flange web to be vertically. If you go to the web horizontally, in the horizontal brace case, it will accumulate water. You have to provide drain hole and accumulate dust. So two cases, okay, we use this type of connection. One is the X brace, cross brace, X cross brace. We want to utilize the largest radius or direction of the plane. And the other case is in horizontal brace case. We want the wide flange brace, horizontal brace, to be vertically, okay? To avoid the accumulation of dust, rain on the web. Okay, so that's the themes. Now we talk about this. That's what we show at the beginning. We connect both web and flange. Okay, the fourth type of wide flange, that's large footprint. Once you connect the flange angle, the gusset plate footprint is large. All right. Now this time we don't want to change this and that, increase the gusset plate size. We don't want to do that or save some time. Okay, so we connect both flange and web, and that pretty much achieve the full tensile capacity of this wide flange. Okay, if you connect that way, it's a heaviest brace. Okay, so the last one will be connect flange angle only. Okay, we don't have the web plate. We connect the flange angle only. You can do that, okay, and that's your choice. I mean, we provide an option. Okay. So that concludes our 1, 2, 3, 4, 5 types of connecting details, okay, for wide flange to gusset. There are 5 types, okay. It's block flange, web using web plate, web using create angles, and create both web and flange, and connect the flange only. That's what is shown now. Let's conclude our wide flange, okay. So we turn these, okay, we'll keep this on. Then we go to WT shape. That's only one way of connecting it. That's what you see here, WT flange, okay. We use WT a lot, okay. The problem with that is the eccentric moment. It has a lightweight capacity. Normally for heavyweight brace force, we go to wide flange, okay. That's WT, can be leg pointing to paper, a leg pointing to toe pointing to inward, toe pointing to reader, okay, point to front of gusset. Okay, we change it. You can go that way. See here, the toe is pointing to a reader. pointing outside. Okay, we have the option of doing that. All right, so that's WT. Now we want to go to next double angle. There are a couple ways. Oh, WT. We finished this one. Double angle. Okay, there are lots of ways how you connect to the gusset. Okay, first is this one. It's back to back. That's what we call it vertical brace. Okay, vertical double angle for vertical brace, back to back. Okay, also this way. Okay, that's more like WT here. We normally do that in horizontal double angle brace. Okay, and also we have star angle like this. Okay, it's not common thing, but you know, star angle is double symmetric, so that capacity is no reduction. Because eccentric moment, no. Okay, these two guys, also that one, your brace member have eccentric moment. Your brace have to design as beam column with axial and bending, so that reduces the capacity a lot. Okay, for star angle, there's no such issue because all these this one has eccentric moment too, because the gauge there's offset from the geometry century. Double angle, star angle has no such issue. Okay, you get full capacity of this double symmetric section, and also single angle connect like this. So we have 1, 2, 3, 4, 4 ways of connecting. The 3 ways of connecting double angle plus 1 way of connecting single angle. That's for angle. We close it. Okay. So now we change to okay 10. We change to double angle vertical. That's what we see. When we okay, so it's back to back in vertical connection case. Okay, double angle vertical and double angle horizontal. I'll show you this one. Okay, double angle vertical, double angle horizontal is like this. All right, close. Horizontal. It's more like a WT. We do it in horizontal brace. Okay. Okay, let's double angle horizontal. If go to horizontal brace case, normally we get this toe pointing inward. Okay, back to behind gusset. All right, let's double angle horizontal. It's this case. Okay, now we go to I'm going to show you the star angle case. Okay, star angle case. Close. Star angle case. Star. Okay. You won't see any other program provide that much options for connecting members on how the double angle connected. Okay, they don't provide you them many options. Our program is only one provide them many options. That's double angle star. Okay, it's this case. Then we definitely the last one go to single angle like this. Okay, single angle. Okay, single angle. And then channel, there's only one way to connect. Okay, back to gusset, channel back to gusset, channel. See here. Okay, channel. The channel back to gusset. Okay, and HS hollow section. Okay, there are lots of way of connecting that. Okay, now we go to tube, hollow section tube, and we have also hollow section pipe, circular hollow section. Okay, whatever you call that's a tube. Okay, there a couple way. Okay, slotted around gusset. I believe we have two tip for this one. I mean, night plate, single plate, lap plate. Oh, we don't have two tip for this one. Okay, it's here. We go to a slot. Okay, just slot into this gusset. We try this one for now. Okay, slot around gusset. Okay, slot around gusset. We just that applies to both tube and pipe. All right, slot around gusset. Okay. The second one will be night plate. Okay, we bolt a single. We call it night plate, single plate. Okay, this way. Okay, close it. Night plate, single lap plate, single lap plate. See that? Okay, night plate, single lap plate. The next one will be T attachment, single plate. Okay, we weld M plate, we weld extension plate. So T attachment, single plate. Let's see. T attachment, single plate. Okay, so well, T M plate, we have single extension plate. We bolt it to gusset. The next one will be double plate. Okay, double plate. That means we weld a night plate, but we provide a double lap plate. That's good for three critical connection because we have double phase, and this way we have some tiny eccentric moment. Okay, some engineers don't like it. Some engineers don't like it. This is some eccentric, tiny eccentric moment here. Eccentric axial loads cause eccentric moment to the connecting plate. For this one, there's no eccentricity. Okay, we offer a double lap plate, and that will increase the thread critical because it's double shear plate. Increase the thread critical capacity by double. Okay, okay, that night plate, double plate. Okay, close it. I go to night plate, double lap plate. Okay. Okay, see what's going on here. Okay, so we have night plate in the orange color, and we have double lap plate. Okay, that's so that concludes my demo on how on a different type of brace member. Different type. We have wide flange, double angle, WT, single angle, channel, and hollow section, tube, hollow section pipe, and different ways. There are how many ways? Okay, the wide flange will have 5 ways of connecting it to gusset. WT only has 1 way. Double angle, we have 3 ways how we connect to gusset. Okay, single angle only 1 way, and also the channel has 1 way, and hollow section we have 1, 2, 3, 4, 5 ways of connecting it to gusset. Okay, that's a variety of sections: wide flange, angles, channel, hollow sections. Okay, WT, that's different sections and different way. Each section has different way of connecting to gusset. We finished that. Okay, so the brace type, fastener type, in some connecting ways we can be bolted or welded. Okay, the last one is the brace incline angle to vertical line. So we have let's say 60. Okay, that angle is always braced to vertical line. Okay, braced to vertical line. See here, we can adjust that. All right. Get 60. Okay, that's heavy brace. That's 60. I don't know why it doesn't show the angle. We turn the 2T off. We turn the 2T off. Okay, and we change the section type to be WT. Easiest way. All right. I want to do a quick demo. I don't want to show you stuff through the complicated brace members. Okay, that's WT, easier to read. So section type we change to WT. Now the easiest way. Okay, see the 60 here. Okay, so basically that's a brace incline angle from vertical line. That's a brace center line. And vertical line, the angle is 60 degree. All right. So if we change to 40 degree, you go to this way. All right. If you change it to 40 degree, it's always to vertical line. In this program, when we talk about angle, the brace angle, center line angle, is always referred to. Well, for the input, it's also always the angle to the vertical line. Okay. So that's 40 degree. So that concludes our first part of brace. Okay, we have coming part. Okay, and I would say that the reason we take this first part first because these under general tab, these input apply to most of our that's a type of brace member and how the brace member connect to gusset. That apply. That's the first part of brace connection. The coming part will be the application of this brace. Okay, like we are talking about vertical brace, horizontal brace, knee brace, chevron brace. Okay, base brace. The application location of this brace, but for the coming part, all these different application location has the same common knowledge on how the brace connect to the gusset. That's what we demo here, because regardless vertical brace, horizontal brace, they have the same approach of the way that have same ways how the brace connecting to gusset, right? Then we apply to different location, like horizontal brace, vertical brace. So we have first briefing on the way brace connect to gusset. It will share between the coming tutorial when the brace apply in different location. All right, so we isolate this part as the first introduction on the brace connection, and under the general tab, these interface, I introduce all these inputs here. Okay, they apply to all the coming tutorial when they apply in different location. So that concludes my first part of brace connection, and see you in the coming tutorial. Bye bye.